last 24 hours on our star. The filament eruption we saw yesterday morning was followed up a few hours later by eruptive behavior on the north. Two separate eruptive events, with the second one releasing a massive plasma filament just south of the polar crown. The latter of those events was absolutely gorgeous in the 304 angstrom view of the plasma release. If you caught our second video yesterday, you already know that the previous eruption is likely to give Earth a glancing blow on November 30th. That's NASA's Enlil spiral. SOHO coronagraphs are now updated, showing the widespread impact coming from the second series of eruptions. It also appears there's an Earth-directed component from those events, and the updated Enlil spiral seems to show the exact same thing. Now, while we are awaiting multiple impacts, we'll be continuing to monitor for more and the pace of the incoming coronal hole. This one's still slated to face Earth in about 2 days and likely to have its solar wind arrive near the end of the weekend. We'll be eyes open on the solar wind and in the corona for all of this activity and its development. Top quake of the last couple days struck Papua New Guinea yesterday, 6.5 just offshore. No reports of significant damage as would be expected in that part of the world. Up first in the article list today relates to the magnetic anomaly maps we've seen in the past. While there is a near global coverage of the large-scale anomaly tracking, there is far less in terms of localized detail, especially in the crust beneath the oceans. New study here is helping to show how ships can be used to trace those crustal fields beneath the sea, adding to the detail of these magnetic maps. They help to indicate where the geology would amplify or dampen the space weather induction. And one of the most common questions we get about space weather impacts from new viewers is, what part of the Earth is going to be impacted? And that's just not how it works. There are global impacts of several forms, and this study is an excellent one on why the night side induction currents can be exceptionally bad. They used the 1989 Quebec blackout example with the specific Hall currents present on the night side during that event.